Welcome to AI for Good, the leading action-oriented global and inclusive United Nations platform on AI. Organized by ITU in partnership with 40 UN sister organizations and co-convened with Switzerland. The goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and scale those solutions for global impact. In today's session, we're counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end, as we will hold a 30-minute networking session in the neural network. Here you can meet, ask questions to our distinguished speakers, connect, and chat with the AI for Good community. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Thank you very much, Anna. A very good day to everyone, and thank you for joining. Welcome to the AI for Good Machine Learning in 5G Challenge webinar session. My name is Thomas Pascal from the ITU, the International Telecommunications Union. The Machine Learning 5G Challenge aims to create a community to solve network-related problems using AI and machine learning. Today, we are excited to host yet another interesting talk from researchers in CTTC. The title of this talk is called Federated Traffic Prediction for 5G and Beyond. As always, we are counting on you, our participants, to help create an engaging discussion. Without further ado, I'd like to introduce today's speakers. Today, we are excited to have three speakers from Telecommunications Technology Center of Catalonia, CTTC. We have Frank, who is a postdoctoral researcher at CTTC. We have Paolo Dini, who is a senior researcher at CTTC, and Marco Miozo, who is also a senior researcher at CTTC. In today's talk, they're going to describe a problem statement with the same title that I've already introduced, Federated Traffic Prediction for 5G and Beyond, which proposes the usage of federated learning tools to predict the traffic in cellular networks collaboratively. During this talk, they also introduce a real data set, and they will describe it. This was done from real measurement campaigns and is being provided to our participants of the challenge. And this data contains like unknown LTE users, the data set from unknown LTE users of commercial operator at 3 different locations. So first, I'd like to welcome Frank, who has been collaborating with us since 2020, the beginning of the challenge. Welcome, Frank, and good afternoon.
Thank you a lot, Thomas, for the nice introduction. So first of all, let me share my screen to show the slides that we prepared for today. I hope you can see them. Yeah, can you see the slides? Can you confirm, Thomas?
Yes, we can see the slides.
So welcome to everyone, and thank you a lot for attending today. It's, as always, a very great pleasure to be here. My name is Francesc Wilhelmi, and together with Paolo Dini and Marco Miozo, we will provide an introduction to the problem statement that we are organizing this year at CTTC for the ITU AI Challenge. This problem statement is about traffic prediction, and more in particular by using federated learning. So before we start with the technical content of today's talk, let me introduce the organizing team and myself. First of all, we have Paolo Dini, the head of the Sustainable AI Research Unit at CTTC. Marco Miozzo, a senior researcher with a broad experience in communications and in machine learning. And myself, Francesc Wilhelmi, a postdoc at CTTC, working on different stuff, on federated learning, blockchain, and other stuff. As said, all of us belong to the same research unit, which is Sustainable AI, where we try to address multiple topics following a holistic approach. Our main interests are on edge intelligence, which means basically working with distributed data, and we are also analyzing and integrating novel technologies like blockchain for that purpose. Another topic of interest is sustainable computing in areas like vehicular networks or IoT. And finally, machine learning operations to meet somehow sustainable goals, which can include, for instance, developing ML-based models for addressing climate change, like developing ML-based air quality models and so on. Of course, we are a very multidisciplinary team. If I am not mistaken, we are 13 people now in the unit, and more positions are opening, so the team is growing. And the team has also a high variety of profiles. We have people from communications, data science, computer science, optimization, and so on. And here you can see our office in a sunny day in Barcelona, very beautiful. And before this problem statement that we're organizing this year, we have participated in 2 more problem statements in the last 2 years. In those problem statements, basically we target the topic of Wi-Fi optimization and Wi-Fi prediction using ML. And as we're going to do this year again, we had multiple sessions, including webinars, hands-on sessions for developing code, for instance, a lot of personal feedback, interactions with participants, and so on. And the best part of everything is that at the end of the challenge, in the last 2 editions, we collaborated with all the participating teams, and we generated an output, which in this case is an academic publication that was published in ITU Journal. No? So this is what we are going to see today. The first part will be introduced by Paolo, the second part by Marco, and I will come back for the third and last part. So now I give the floor to Paolo, who will briefly introduce the traffic prediction problem in communications.
Okay, thanks, Francesc, for giving me the ball. So let's see the importance of traffic modeling in general in mobile telecommunication network, and in particular in next generation network like 5G, but even in the future 6G technology. In fact, nowadays we have a plethora of services and a nice number of devices that are also heterogeneous in nature. So they are creating different traffic patterns and heterogeneous traffic pattern with different requirements. So if we can understand the hidden characteristic of these traffic demands, is very useful for a mobile network operator to manage the infrastructure and to monitor the infrastructure for the proper functions, and also for at the beginning of the deployment, for the planning itself, for example, for understanding where to place base station and to provide coverage to the user. So as mentioned, we have a very high number of variety of services which have a very different requirements. So it's important to collect the data that we have. So normally what we are doing when we are modeling traffic, and in particular in our case that we are focusing now is predicting, so knowing in advance what is the new request for the new user. We are collecting data from the different devices or interfaces of the infrastructure, and then we are kind of sending this data to a central server that is processing the data in order to generate prediction. So this implies some issues in this normal operation. The first one is the security breach, because mainly what we are capturing are data from the users that are generated contents. So there could be a privacy issue there. That is also some problem in terms of efficiency, because of course we have to monitor different interfaces. I recall here that mobile infrastructure is distributed in nature because we have several base station router servers. So we have to monitor different infrastructure, and then we have to send what we have collected to a central server. So there is also a communication cost that can be also a problem and creating congestion, because the amount of data that we need for understanding the traffic pattern could be very, very high. For this reason, nowadays, there is this trend in research and industry to go distributed, what is called edge computing, and so to collect the data and directly process the data where we are collected. And one special way of doing this type of processing and learning procedures distributed is called federated learning, which will be our focus in the next problem statement that we are presenting. So if you, okay. So normally traffic prediction is a time series forecasting problem. So we have several methods that can be applied to understand this prediction problem. In particular, from the machine learning community, a vast number of papers has been published regarding the application of ARIMA or random forest or KNNs or Verbatim machines as well. So this type of classical, let's say, machine learning methods are kind of having some difficulties in capturing the hidden characteristic of the traffic nowadays, because they tend to stack on the average pattern, and they are failing to capture the very high dynamic of the service nowadays. So for this reason, the inclusion of deep learning methods is now a kind of key application of for traffic prediction. So in particular, convolution and recurrent neural network are those that are more used for this type of problem. So we are recalling here also in the picture the importance in the nowadays development, like those that are called as ORAN, so these open software radio access network, in which we have different application of traffic prediction that can be used for traffic steering, for slice management, for resource allocation, quality of service optimization, mobility management, and so on and so forth. So with this, I complete this part, general introduction, the need of traffic prediction in beyond 5G networks. And I pass now the word to Marco for the next part.
Thank you, Paolo. So as introduced perfectly by you, now let me speak a bit about the data set, the data and the SuperCom framework. As introduced by Paolo, for doing such a framework or for make the prediction, we need data. So we need to collect the data from our environment, and we need to explore the data. So we need to know what the data contains, and also and also we need to process the data finally. So we need to, what we've done is to create a framework for including all these three aspects. And this framework is called SuperCom, which stands for Sustainable High Performance Computing Platform. And you can find it, the web interface in the link in the slide. So the idea is, as introduced by Paolo, that we need, in order to perform this kind of operation, to collect the data. So we'll have a section devoted to how to collect the data, both LTE data, as we present in this seminar, but also other type of data. For instance, the data that has been used in other challenges like the Wi-Fi 1. It can be either data from real world, but also from a simulation perspective, as is in the case of Wi-Fi. Then we have the data exploration, in which you can download the datasets and use it, and finally the data processing part, in which we provide some scripts for playing with the data. So either do some exploratory data analysis or doing some prediction or other artificial intelligence tools. So considering the data of this talk, so the LTE data, in order to obtain it, we used a tool based on the old framework, which is a public, an open source framework developed by SRS a few years ago, which is devoted to decodify the LTE control channel. All the messages that are sent that you can send with your mobile phone are managed by the base stations through controlling through a mechanism that, in order to control and avoid and allow you to transmit data. This is done through the physical downlink control channel, which is a specific channel that is not crypted. You can perceive it with an antenna and decode it. Of course, in this case, there's no, you cannot access to the data, but you can have an idea of what is happening in the channel by decodifying the so-called downlink control channel information, DCI's messages, which contains all the information that your mobile is using for decoding the data that you are receiving and also you are sending, both for the downlink and uplink channel. The main features that are important for the context, but in general that are interesting, are the RNTI, which is the radio network temporary identifier. So it's the temporary identifier that the base station provides to the end user in order to identify him. It is temporary, so it allows to it is changes so quickly that it allows that the user cannot be identified with this identifier. The modulation coding scheme, which is the quality that the transmission can be performed, and this depends a lot on the quality of the channel, of course, and the number of resource blocks used per frame, and also some hybrid queue information, so how to retransmit the messages. This information are in the DCI, which is, as I said before, is the control channel, which is the blue part of the figure, and then we have the data, which is the yellow part in the figure on the right side, bottom right side of the slides. So it's important to remark that we are not dealing with actual data, but with the control channel. So we have all the information. We have all the information that the devices needs in order to decode the data that is sent. So regarding the specific data set and challenge, in this case, we used this framework in order to collect the data from a few interesting spots in Barcelona. So in order to do this, we install the code in a specific computer, which can be a laptop either, and the code for codifying the LTE messages, there's the whole framework in a SDR platform, so in a software-defined radio platform. We put this in a specific zone. One of these is the Les Corts Barcelona, in which the Camp Nou Stadium is close by. So the other two ones are the Poble Sec, which is a residential zone within the city center, and the third one is the El Born, which is another residential touristic zone in the middle of the heart of Barcelona. where the cathedral is, in order to make you aware of the zone. So there are 3 popular zones of Barcelona. We collect different kind of outputs. One are labeled in order to decode specific services such as YouTube, Vimeo, and Spotify. And the others are unlabeled, which is our focus. So we collect, in practice, the DCI messages in order to have an idea of what was the traffic within the specific period. All these datasets are oriented to academic and research purposes. So they are they are public, but in order to access them, you need to ask through the website the access. It is important to highlight that, as I introduced before, we do not provide only data. The Supercom is not a platform just for data, but also we provide some baseline machine learning models in which we have processed the data. Also some exploratory data analysis, so in order to have an idea of what is happening in the dataset, which is pretty important in order to implement efficient machine learning models. Some script also for data visualization, and also for explainability, so some explainability tools which are very important in order to understand the behavior of our machine learning models, but also to improve the efficiency of such models. So as soon as we have some insight of what they are doing, you can improve the model itself. So concluding, we have already done some work. You can surf a bit our web, in which we provide also some papers, as the one I put in the slides here are the ones that are more related to this challenge, even if they are not devoted only on prediction, but as you can see, we have also different applications such as anomaly detection and also classification, which will be not treated by this challenge. So in order to give you a more clear view of what we have already done, Paolo is presenting one of this paper, the one of traffic prediction, the second bullet. So let me give you to Paolo the ball.
Yeah, thanks, Marco. So in this paper that we published some years ago in PIMRC conference in 2018, what we have done is to apply recurrent neural network model for, in particular, the one that is using low short-term memory cells for predicting the traffic of 2 different sites in Barcelona. So we have chosen LSTM because of is able to address partially, I'd say, the vanishing gradient problem that is typical for the classical recurrent neural network, and we have compared with classical time forecasting model like ARIMA, and we also use another benchmark for comparison, which is classic feed-forward neural network based on multi-layer perceptron. So you can see here the architecture that we use. So we are observing the traffic sample for a given observation window of a given duration, and then we are providing the forecasting sample for the subsequent time, but also for future steps. So we try to address not only the T+1 prediction, but also in a given observation window, and we have performed some experiments, and we see how this type of architecture can lead to a very high accuracy. So in this case, we show here the error in the prediction error, so which is very it is lower than the other 2 proposed methods. So we believe this is a good starting example for the challenge that we are going to present in this year, and that now Francesc is going to give more insight for the subsequent part of the talk.
Thank you, Paolo. Thank you a lot. So basically, as anticipated, and this year we would like to propose the usage of federated learning for the traffic prediction problem using the dataset in SuperCom. Basically, this is the idea. Federated learning, in short, it is a framework for decentralized learning that was introduced by Google back in 2016. And some of the characteristics, some of the good characteristics of federated learning are privacy, that it provides less overheads compared to centralized ML architectures where you need to send the data to a central point. It also offers high scalability, properties like fault tolerance, and the fact that you can easily produce specialized models is also a very nice feature of FL. For the traffic prediction problem, the goal will be what Paolo mentioned, which is predicting up to n data points based on a set of k past observations. The model proposed by participants in the challenge will need to be trained in a federated manner, meaning that you have a set of FL devices that iteratively exchange model updates, not data, to build a collaborative model, in essence. In particular, in a federated learning application, like the one that I show you in this figure, in this slide, is that you have a central server that is in charge of the orchestration for a set of users and to produce global model updates. So to be a little bit more precise, first of all, we have the server that sends an initial model to all the users. So all the users can start with the same model. And each one individually will provide some local training based on their own data. This data is not exchanged. And after they produce some local updates with this local data, they submit these local updates to the server. And the server, of course, gathers the outputs of each user and performs model aggregation. And this procedure is repeated until convergence, basically. As for the evaluation of the model, we will focus on the normalized root mean squared error, which will allow us assessing the quality of the predictions that basically your models will provide. Here, I wanted to show you some useful tools for building FL models. So in principle, you can use the language that you want, or you can provide the kind of solution that you want. But here, there are two very popular frameworks that can be of great utility. One is TensorFlow Federated, which is basically an extension of TensorFlow for simulating federated learning applications. It is very simple to use out of the box. And in case more in-depth extensions are required, it provides a set of APIs that can be very useful as well. However, the problem is that these APIs can sometimes be a little bit hard to manipulate, and sometimes documentation is deprecated. So depending on what do you want to do, maybe you will find more difficulties. And the other framework is PyTorch, which is very flexible and suitable for building custom applications. In particular, there is a framework which is called PyShift, which is an extension of PyTorch provided by OpenMinded. And this extension is basically for the implementation of secure, decentralized ML and federated learning. And finally, let me say that with PyTorch, you can easily execute PyTorch in many types of devices like Android devices and so on. So for production applications, maybe PyTorch is more mature nowadays than TensorFlow Federated. Here, I provided a snippet of code that TensorFlow Federated provides for illustrating their module. Basically, I find it very illustrative because here with this a small number of lines, you can implement an entire pipeline for federated learning. Here, as you can see, it is a little bit small. I apologize for that, but basically you have a first module for processing, loading and processing the data. Since TensorFlow provides inbuilt data sets, this is super easy in this case because they have like a set of data sets, in this case, MNIST data set for digits and characters, handwritten recognition. So basically, you load the data set, you divide the data set, you divide the data set into pieces, each piece belonging to a different user. After that, you define your neural network or whatever ML model you want to define for performing local planning. And finally, you simulate everything here because here, the implementation that TensorFlow Federated provides is pretty straightforward because they defined the entire pipeline, or better said, the entire federated learning process, including the interactions between users and server and so on. But basically, if you would like to implement that, you would have to implement, first of all, the local planning in users, the server aggregation at the server, and also the communication between the users and the server. Okay, our dataset, as Marco introduced, contains LTE measurements that allow determining the traffic load at a specific site. In particular, we have 3 different sites, which are at different areas in Barcelona. The beauty of the dataset is that the nature of each location is different and that the number of measurements in each location is different too. And I say that the beauty of heterogeneity is that because it is a very interesting problem to see and quite a novel one. So with an heterogeneous data set like this, what we want to prove or what we want to achieve with this challenge is whether the federated learning approach is able to take the best of each site and generate a strong global universal model that could be applied for all the sites or not. Here, for instance, PobleSec, which is a centric place in Barcelona, we have data for 28 days. In Elborn, we have data for 7 days. And in Las Corts, we have data for 12 days. No? Here at the bottom, you can see a kind of summary of each location's data sets. We have PobleSec at the left, Elborn in the middle, and Las Corts in the right. No? And basically here you can see that there are cyclic patterns, but also there are different peaks that are not correlated, and also irregular patterns, which basically stem from the characteristics of each site. No? For instance, in Las Corts, as Marco said, the location is very close to Camp Nou Stadium, which is the stadium of Football Club Barcelona. In that stadium, when there is a match, a lot of people surrounds the stadium, so the traffic increases a lot. So here we have a peak that probably corresponds to a match day. In Elborn, on the other side, this is a very centric and touristic area. And apart from that, it is an area where there is a lot of nightly activities. There are a lot of popular bars and people go there in the night to have a good time, no? So probably we can have more peaks in the weekends than during the week, no? Or we could have even more peaks during summer season because there are more tourists or people is not working all the days and so on, no? This is simply a screenshot of the data set to let you start becoming familiar with it. As you can see, we have the timestamp and we have a set of features for each time. So what's next in the problem statement? First of all, we will publish the dataset, which will be prepared for building FL models. As mentioned, the dataset includes measurements from 3 locations. It has features like the temporal identifier, modulation and coding scheme, number of allocated resource blocks, all in the uplink and in the downlink. What you will have to predict in this case is the transport block size, which here the notation is up down, but probably we will amend that. But this is the transport block size, which is basically a combination of the modulation and coding scheme and the resource blocks allocated. And after we will provide this data set, you participants will need to develop a federated learning model, and this model will be submitted for evaluation. The models will be evaluated in a new test data set that will not be revealed before the evaluation is done. And to follow the entire challenge, of course, you will have updated information both at the official ITU AI Challenge website and also in Supercom's website, where we have a section for the AI Challenge. And that's all from our side. Basically, we can only say stay tuned because a lot of useful information is to come, information about the logistics of the challenge, how to register, where, when, how much time do you have to prepare your solutions, which are the prices, whatever. And thank you a lot for your time. Thank you a lot, Thomas, for the invitation and all the AI Challenge team for giving us the floor. And that's it. Thank you.
Thanks a lot, Frank, Paolo, and Marco for this nice introduction of the first problem statement for the 2022 ITU AI and Machine and 5G Challenge. As already Frank has illustrated, stay tuned. We will announce the registration details in the coming few weeks, possibly by the end of this month. So now I would like to go into the Q&A. Vishnu, good afternoon.
Thanks, Thomas. Good day, colleagues. Thanks, Frank and colleagues. It's an excellent problem statement, and you are here for 3rd year in a row. So thank you so much for coming back and participating and collaborating. It's a great pleasure. I have one fundamental question, that is, your data is related to control channel, it appears to me, but your prediction, is it related to control or user plane? That's my question. So your collected data looks like this PDCCH and PUCCH, it looks like that. But you are looking for prediction in the control channel or in the data user channel, please.
Marco,
Okay, I can.
Yeah.
Maybe, thanks for the question. Is a good question because I try to explain, but let me try to explain more in depth. The data is related to the control channel, but capturing the control information of the channel, we can have a view of what is happening in the data channel. So the control channel is providing us this information, so that are the one that used by the device in order to decode the data that is transmitted to it. So we do not have access to the data, but we have all the information of the transmitted data. So we can make the prediction of the actual transmitted data just having a look on the control channel. So without having an in-depth inspection of the channel, which are actually, from our perspective, is also more energy efficient, of course. Okay, thank you so much. There is a question from Sar on computing power. Basically, it is about resources. I had the same question. As you know, most of the participants may be using free resources to participate and compete in the challenge. So how do you see the use of GPUs? How do you see the use of other kinds of resources for training and inference? The specific question is about power-hungry algorithms, but could you handle both algorithm part and the resources part for training and the inference also, please?
Paolo, do you want to take this one?
Yes, of course. So it's a very, very nice question, in my opinion, because it was one of the key topics, the key reason why we want to focus now on federated learning, because it's one way of distributing also the computing power across different nodes. So the fact that we are working distributed and at the edge, it is also decreasing the complexity of the algorithm. And then what we are doing is also not to share the data, but the model. So this is also decreasing the quantity of information that should be transmitted. One way of distributing also the computing power. I have some echoes. I don't know what. And then I don't know if it is partially addressing the question. The other thing that I wanted to mention here is that the amount of data that is included in our dataset can of course be managed by a GPU very fast. Of course, with an increase in power consumption. But in the past, we have also used simple CPU for processing our data. So for the people that want to attend of the challenge, if they don't have access to GPU-based cluster, they can of course use CPU-based with a bit more time, but it's completely manageable. So I hope this also attracting a high number of participants, because the idea of having models and algorithms that can run on different platforms is also one of our interesting topics that we want to tackle with this challenge as well.
Mm-hmm. Thank you so much. There is the granularity of prediction. I want to ask you about how the inference, the traffic prediction has to be granular. Are you looking for next few seconds of data or few hours of prediction? What is required from the participant to be predicted? Which time window is required to be predicted?
In this challenge, we are handling windows of 120 seconds, so basically 2 minutes. We still need to decide which will be the number of observations that we will allow participants to use before generating 1, 2, 3, up to n predictions, no? But basically we have windows of 120 seconds, no? Which is a good number based on previous work on this topic, no? On the same data set. Maybe Marco could develop a little bit more on this, or Paolo.
Yeah, if you want, I can say that one of the things that are interesting to study is the number of samples that we need as input. So as Frances mentioned, we will have data sample every 120 seconds, so 2 minutes. So the idea is then to have at least the subsequent prediction, but then it's also a part of the study, in our opinion, to understand which is the accuracy if we go farther the next point, the next sample, and we believe this is part of the challenge, not to understand how accurate and robust is the model for prediction that are longer than the next step. So we believe that this is not so long period of time because of our previous experience on the data set. So we know that the dynamicity of the data sample is very high, but of course we can go a bit more than one point in the future.
Thank you so much. Actually, one thing which we really think is important is the tool sets that you mentioned. I think the TensorFlow federated and the PyShift, these tool sets are really important for the participants. I think this is, thank you so much for bringing this up. Actually, I also see that Abhishek has pointed us to Flower, which is also quite interesting in the chat. If you see, Abhishek has pointed out to Flower. I was checking that. That's also quite interesting framework, looks like. The question is on notebooks, Frank. Do you have or do you plan to give reference solutions which give a sense of what needs to be done and how to use these frameworks together? Do you plan to publish or do you plan to help the participant with such reference solutions, or even the results? I mean, do you have benchmarks which they can compare against?
Yes, a very good point, Vishnu. About the notebooks, the Colab notebooks, for instance, I am pretty sure that we are going to provide some. In fact, we have a lot of code in SuperCom for data visualization, for data processing, for taking the data sets and processing the data sets. We have also baseline mechanisms like convolutional neural networks or the LSTMs. Based on that, we will provide assistance, and of course, we have been working a lot with TensorFlow and PyTorch. So these are the tools that we are comfortable with. I know that Flower can be a good tool. So if anyone is deciding to use this framework, it is more than welcome. But I think that we can provide better assistance with TensorFlow and PyTorch in the particular case of federated learning. And as for baselines, yes, we are going to provide, I think, some baseline results that we have on the same data set for centralized model instead of federated.
Thank you so much, Frank. That will be very useful. One of the things, as you know very well, we are trying to increase the learning for the participants, and we would like the participants to also learn from you. So it will be very useful for if you give out such reference solutions. Do you have any guidance on the split of data? So you mentioned about federated learning, even in the TFF that you showed. There were components which were actually training. I think the learning was happening in a federated manner. How should the participants split the data? Do you have any? I mean, you did talk about 3 physical locations, but that may not be the split. So that's why I'm asking. Is there any guidance on the split of data?
Yes, in fact, the split will be based on the sites. So we have 3 sites, so we have 3 users, and we will provide all the data prepared to be used by FL models. No, so basically we will provide an entire plain data set with measurements for obtained during several days. And it is up to participants to split that data into training and validation, for instance, for performing the training. After participants provide FL models, in this case, and predictions on the training data set, we will provide a different data set, which is a test data set, also for the 3 locations. No?
Thanks a lot, Frank. Yeah.
Thank you.
You want to add something, Frank? Frank, did you want to add something?
No, that's it. I wasn't finding the unmute button.
Okay. Yeah. Yeah. I think about the evaluation criteria. So most of the time we get questions around how we can win this competition, right? So how do you evaluate the participant, and how do you give scores, and how a participant can win this competition?
Okay, so basically we are going to use this metric in a first phase of the challenge. This means that when we get the models from participants, we will take the test data set and compute this. Based on that, we will make a ranking, but this does not mean that the winner is the participant with higher accuracy, with a lower loss. Because after that, they will need to provide a report. Basically, they will need to defend their solution. They will need to justify their solution. And that, of course, will be evaluated in the final if they succeed to pass to the final. And there is where the prices will be decided. No? So this is not a matter of getting the best score, which is very important, but it is also a matter of defending what you do, of justifying your decisions and understanding the problem as well.
Thank you so much, Frank. How are you evaluating the federated nature of these solutions? You mentioned it's not only accuracy, but also you don't want a centralized solution to win, right? Because this problem statement is about federated learning, right? So how would you evaluate that part of the solution?
there are two parts, no? Because in federated learning, in the end, you build a global model that can be used for everyone. But the difference is that you build that model based on the interactions among users that are exchanging model parameters instead of data, no? And you kind of average or aggregate the model of each participant in essence. So one thing that we can do is taking this global model generated by this collaboration and evaluating how that model performs in each of the sites. Another thing that could be done is something that I mentioned at the beginning for federated learning, which is about specialized models, but this is something that we are not going to target in this problem statement, no, in this challenge, because for specialized models, you can have basically models that are the same for, so you can have unique models for each user or for a cluster of users, no, which share certain similarities in some sense, no? But as said, we are going to take this global model generated collaboratively through federated learning and evaluate it in each of the sites that we want to study.
Mm-hmm. Thank you so much. About the next steps, so you just now mentioned about the next possibilities. I want to ask about publishing opportunities, because some of our participants would be interested in papers or other kinds of publishing opportunities, papers, articles, academic papers, or research publications. What are your thoughts upon it? And could you? I know about the previous work that you have done. So could you describe what you are planning to do after you are done with this challenge, and how you are going to go about the next steps of taking this, pushing this research envelope forward?
Okay, maybe I can hand over to Paolo or Marco, because otherwise I will be here all the time.
Yeah, I can take it, no problem. So we as an academic institution, we of course will explore the possibility to have a publication out of the result that we will get. So this is one of the things that we would like to, of course, to use and to collaborate with the participant in this sense, which is one of the one important goal for us. And then based on the result, we can enlarge also the topic, and then based on this, maybe there could be the possibility for the participant to start a more, let's say, established collaboration with us through fellowship or other kind of fundings in this topic that is coming out from this initiative. So this is more or less the general idea for the outcome for us.
Thank you very much, Paulo. I mean, I want to add that, of course, ITU will give out certificates and prizes at the end as well. So I think this is a very exciting challenge. I want to ask one last question, because you are doing measurements outside the network, because, you know, as you explained, your measurements are basically happening using the OWL framework and not from the UE based feedback. No? So I think this is quite interesting, because you're basically getting data from the environment. This is very interesting. I think this kind of outside measurement or external measurement, if I can call it, is very interesting, and it has, I think, a lot of applications in standards and implications in standards. I think you know what I'm talking about. I think that's the future of this kind of solutions, where we have measurements from the environment. It will be quite interesting to look at. I think the question what I want to ask you is about standards. What do you see for standards in this area? In ITU, 3GPP, or anywhere else? Do you look at pre-standard or standards-based research in this area, where you get measurements from outside and use that for optimization of the resource allocation, maybe because of traffic prediction or whatever? So I want to ask you about standards in impact or opportunities.
Francis, do you want I'm taking this?
Yeah, okay. I mean, data measurements from the outside of the network can be, in my opinion, super useful, not only in the context of ML optimization and so on, but you know, Vishnu, that we are also working on blockchain technology and other things that have not yet been standardized in deep. So basically, these data measurements from the outside can help a lot in validating, in providing blast to certain operations in the network, no? So the ability of having validators who could validate based on external measurements that some activities planned in the network are going well, it is quite a powerful topic, no? This is super related to oracles in blockchain. If you are interested, we can have a different talk on that, because this is quite a broad topic.
Paulo, you want to add something?
No, basically what Francesco said is I totally agree. I also wanted to mention that this kind of activity that we are carrying out on traffic modeling have an impact on the let's say operation of the mobile infrastructure. So we are trying to understand the possibility for us also to enforce this type of measurements and then modeling to 3GPP standardization body, which is the one that is related closely to mobile networks. And then the usage of control channel instead of the packet extension maybe could be a good practice for mobile network also to reduce the quantity of traffic, the amount of traffic that you need for some modeling for different purposes, no? Because this has an impact on traffic steering, mobile radio resources, even network slicing. So there are many functions that can use this framework. So maybe standardization body can try to we can enforce this approach to 3GPP.
Thank you so much. Yes, I think exactly what I was thinking. Yes, I think this is quite exciting problem statement. You are the right, or rather, the participants would be in the right track if they are interested in this kind of activity. I do see a lot of good future, especially in the standards, as you see, and the extensions of this and publication opportunities. We are over time. Thank you so much for staying back and answering all the questions, Frank, Marco, and Paolo. Over to you, Thomas.
Thanks a lot, Vishnu, for the Q&A. And I would like to thank Frank, Paolo, and Marco for making time and also for proposing a problem statement for this year's challenge. We thank you so much. And we are looking forward to the interesting collaborations, interesting solutions in this year. At this point, I would like to close the session, but we are not finished yet. We are going into the networking. So still stay on the neural network because our speakers will be heading over there and then have a chat with everyone. As we already announced, the registration for the challenge will be announced in the next few weeks to come. So you can register and join and start working on some of the problem statements. We'll have more webinars that introduce problem statement for this year in the coming weeks. Stay tuned. And also you can join us on the challenge Slack to interact with other participants. So thank you so much and goodbye.
Thank you for participating in today's AI for Good session. We hope you've learned something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the satisfaction survey, connect with interesting profiles, or speak one-on-one using the chat and video function. After the 30-minute networking session, we invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits and poster boards, and build your personalized AI for Good program. It was a pleasure learning with you today. See you at the next AI for Good.
Thank you.